This is problem 12.4 from chapter 12 of Brigham and Houston's Fundamentals of Financial Management, Concise 9th edition. And here we're doing a really simple replacement analysis. Okay, the Oviedo company is considering purchasing a new machine to replace an obsolete one. So they're currently using the obsolete machine, and it has a book value and a market value of 0. Now, the book value of 0 means that it's fully depreciated, and the market value of 0 means that they can't sell it to anybody for scrap. However, the machine still works and will last at least another 10 years. So it has value to Oviedo, it just doesn't have any value to anybody else. The replacement machine is more efficient, so it'll do the same job as the existing machine, but better, faster, smarter. And what they figured out is that after taking into account all the labor savings, the difference in depreciation expenses, and the tax effects, they've done all those calculations already. And most of Chapter 12 is showing you how to do the calculations. But in this example, they've already done them for you. So the net is that it saves $8,000 per year. The new machine will cost $45,000 delivered, installed, and plugged in, and it's got an economic life of 10 years and 0 salvage value. The 0 salvage value means there'll be no terminal values. If the weighted average cost of capital is 0 and the marginal tax rate is 35%, should they buy the new machine? Well, a lot of information you didn't need because they already did all the calculations for you. Times 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the time periods. And if we plug in the cost of the machine, it would be $45,000 initial investment, and then $8,000 positive cash flow after tax for the next 10 years. If I calculate the present value of the future cash flows, at a weighted average cost of capital of 10%, then that $8,000 a year for 10 years has a present value of $49,156.54. The initial outlay would be $45,000. So the net present value, which is the present value of the future cash flows minus the present value of the initial outlays, the net present value, or the NPV, is $4,156. So yes, they should replace the machine. It'd be the same as finding a sack with $4,156 in it. So it's an immediate gain. Now, they're going to get $80,000 a year over the next $8,000 a year over the next 10 years, a total of $80,000. But that's the same as having $49,156 today. All right, that's the present value of those cash flows. In order to get these 10 cash flows, they have to spend $45,000. So taking the present value of those 10 years of cash flows and subtracting the initial investment or the initial outlay, that's where you get the answer. And yes, replace the machine. By the way, we could have also gotten that from an IRR analysis. If the internal rate of return on this investment, you invest $45,000 to get $8,000 a year, as long as it's earning, more than 10%, then you should go ahead and undertake the project. So it costs you 10%, you invest, the investment earns 12%, it costs you 10%, you're going to earn a positive spread.